Hello, everyone. Thank you very much for your presence and for your interest. I am so happy to be here, and I thank Augusta University School of Computer and Cyber Science, Dean Alexander Schwarzman, and the university leadership for this wonderful opportunity. Drones have changed the tactics of war forever. They are an integral part of combat operations. Drones are used for round-the-clock and all-weather intelligence, to strike the enemy on the battlefield and to destroy objects and equipment deep in the enemy territory. Now, FPV drones carry out up to 80% to strikes during the war in Ukraine, and their effectiveness is comparable to artillery systems. The importance of drones is increasing due to the lack of the required number of artillery systems and ammunition. The cost of one FPV drone ranges from $600 to $1,500, while the price of a 155 millimeters projectile has reached $8,000. Now in Ukraine there is the world's first full-scale war with drones. 67 UAV strike companies were formed in the combat units of the Ukrainian army. They hit more than 15,000 targets in just 7 months. For example, just one UAV unit of the 47th Separate Motorized Rifle Brigade of the Armed Forces on Ukraine has destroyed 2,500 soldiers and 300 pieces of Russian equipment over the past 8 months. A video of the use of UAVs by this unit is shown on the next slide. The effectiveness of the Russian army use the drones is also high. According to open Russian sources, in just 2 months they have destroyed about 970 units of military equipment. And although we don't have confidence in these figures, we understand the significance of the problem. Russian sources also show the intensity of their use of UAVs over the past year. This slide shows a video. Next slide shows a video of using the most effective UAV Lancet of Russian army. A special feature of this UAV uses a computer vision system on board to identify targets and conduct an autonomous attack on the last part of the trajectory. Ukrainian developers also created an analog of Lancet. It's called Bulava Maze. This drone was presented at the YOLO 2024 exhibition, which took place in France. This slide shows the characteristics of the Bulava UAV taken from open sources. Considering the role of drones in war, the leadership of the armed forces of Ukraine decided to create a new type of troops, the unmanned systems forces. You can see photos of the best UAV unit commanders on this slide. However, using FPV drones on the battlefield has shown that only 20% of attacks are successful. The reason of this is the work of the enemy's electronics warfare and insufficient training of operators. According to the Chief of Staff of the French Army, Pierre Schil, UFV drones will soon lose their dominant role on the battlefield because of the development of electronics warfare systems. And this is indeed a problem. According to the data of the headquarters of the ground forces of Ukraine, in just 1 week of June this year, 7,970 enemy UAVs were destroyed by Ukrainian electronics warfare systems. What could be the solution to this problem? One of the ways to improve the efficiency of UAVs in the development of UAV is the development of computer vision and artificial intelligence systems on the board drones. To develop a new generation of UAVs with artificial intelligence, our team sets itself the following tasks: the ability to conduct autonomous operations at short and long distances, insensitivity to electronics warfare systems, automation of UAV control on complex and dynamic trajectories, insensitivity to weather conditions and time of day, creation of a scalable and customizable embedded platform for autonomous UAVs. All these problems can be solved by creating a platform with built-in computer vision and artificial intelligence systems on board. On this slide, we present our view on solving the problems. An inexpensive platform for building autonomous military UAVs that are capable of performing reconnaissance missions or destroying military targets independently or in groups. After visual acquisition of the target, the aircraft can attack the target without the involvement of an operator and without being blocked by electronics warfare equipment. The platform can be used to create various classes of autonomous UAVs. The platform allows you to adapt the attack trajectory, taking into account the type of target, its menus and weather conditions. The platform provides multiple targets tracking and dynamic target switching. The platform can be configured and adapted for any target UAV. The general characteristics of our UAV are presented on the next slide. You can see they are almost identical to the characteristics of the Bulava, except the lower cost and higher altitude and flight speed. Lower cost is achieved by manufacturing the aircraft body on a 3D printer. Another advantage is the easy scalable of production and its dispersal in different locations, which reduces the possibility of their detection by the enemy to strike. The next slide shows video of flight tests of our UAV.
Is it under AI control or?
No. It's this video only with operator control. The electronic architecture for our drones is standard for UAVs with a computer vision system. The main computing units for implementing the neural model and tracker algorithms is a companion computer based on the Orange P5B single-board computer. It's worth noting that this solution can only cost around $1,200. However, the main innovative component of our development is the onboard computer software, a detector based on the YOLO neural network and the tracker, an algorithm that captures and accompanies the target during the attack. The results of these algorithms are transmitted to a control algorithm, autopilot companion, which calculates the displacement of the target center relative to the camera center and generates the necessary control signals to compensate for this displacement. Integration of the autopilot companion with a standard autopilot, such as ArduPilot, is carried out using the MavLink protocol. This approach allows you to implement the following target selection scenarios. First, automatic target selection without operator confirmation. Second, semi-automatic with operator confirmation. And third, manual. The operator sets the target manually and then the homing algorithm is triggered. The algorithm recognizes objects, samples of which are contained in the data set. It detects them and localizes their spatial location. This localization is presented in the form of a bounding box, a frame around an object, indication with the classification accuracy. The high quality of a trained neural network model is confirmed by the testing results. To train the model, we create a data set, many sample objects for different classes of equipment: cannons, trucks, armored vehicles, tanks and infantry fighting vehicles, airplanes, helicopters, air defense systems, and ships. The dataset included objects from real videos and synthesized objects. The dataset contains about 120,000 samples. However, we left only the three richest classes for testing: cannons, trucks, and armored vehicles. This video shows tests of detection and tracking targets by the algorithm on the UAV board. We can see bounding box around the targets. It's vehicles on this slide. This slide presents our R&D strategy. We are now at the stage of completing tests of the first version of the systems and preparing for its transfer to the battlefield. In the next stage, we plan to create autonomous systems for attacks on targets deep in the aggressor's territory, systems capable to controlling a swarm of drones, as well as systems for civilian use. And this slide shows our development team, which is called Advanced Cybermachines. The team includes developers from leading IT companies in Ukraine, scientists, teachers, and students of the national universities of Ukraine, from Kharkiv city and Kyiv. And so, thank you very much for your attention. God bless America. Slava Ukraini! Thank you so much. And if you question and if you speak slowly and clear, I try to answer for this question. Please.
Are these attack drones, are these operated through line of sight only? You said 60 miles.
60 miles. Yeah.
60 miles. Are those line of sight? Do they need to be tied to your operator, or can they go via satellite or anything like that?
Okay, thank you. On long distances in the aggressor's territory, the only operator need only start fly only, and after that, its all trajectory is autonomous. And on the last part of the trajectory, beginning work our algorithm of recognizes classification, and after that target is captured and autonomous algorithm take autonomous attack on this target. During the way from operator to target, and our plan is not controlled by operator. Understand? Thank you.
So if I heard that correctly, is it that from start to finish, like the takeoff and hitting the target is fully autonomous, or is it more of a hybrid where the operator is able to control up to the point that they can see the target and then it's autonomous?
Может. Thank you. Maybe we have three scenarios. First, scenarios in deep distances in aggressor territory. It's all autonomous, and if we need to see this target, we can use the radio channel for maybe closed radio channel for view on this target, and after that, operator sets this target for attack. It's maybe various scenarios.
And just to follow up on that, if it is an autonomous journey, I guess, from start to finish, what does the input for that mission look like? Is it a geogrid location with a description of what is trying to hit? I'm just curious what the input is for that particular complete
Okay. It may be on GPS navigator, or it may be other type of control during the destinations of target. It may be using photos with object, and during the way to target we can recognize, yeah, and this objects, static objects on the land, and change trajectory for target.
How does the AI learn both targeting and location information? Is it intelligence input? Is it a large language model where I'm storing historical missions, things like that?
Yes, they are using the neural network based on the standard neural network as YOLO or other convolution neural network. It may be SSD neural network, and other. We take YOLO 10 nano neural network for training our model, and we create a data set with many samples objects. It's tanks, cannons, and other. And training this model for object from this data set. And we created this data set 6 months. 6 months from open sources and synthesized objects.
It seems like you would want to go faster. 6 months seems pretty good.
Faster? No, it's we have a big team of students, and it was very hard job, hard work.
Сколько требуется, чтобы натренироваться, не собирать информацию, а натренироваться?
Training, yes. Sorry. How many times to training? It's not so long time. It's maybe 1 week. But after that, we need to fine-tuning this neural model, because we have many thousands of characteristics of this model, for which we can change for high quality of this working of this model. But the main problem for this development is implement this neural model on the board of drone. On the board, it's very hard problem, very big problem for everything.
So implementing it on the drone is the hardest part. That's what I heard.
Because of limited resources on the board?
Yes. It's not very big sources computer, a single computer on the board. Yes, this is indeed a problem.
Are you able to receive feedback from the UAV once it goes from the UAV's AI, once it goes autonomous, that you can before it destructs essentially? Are you able to get that feedback back into your model then, or is it pretty limited on what the UAV can push back before it?
Okay, thank you. Only during the testing on the polygon in our in Ukraine, there are many locations for training drones, and our team now in Kiev, and second team in Turkish. We have 2 locations for testing our drones.
Turkey?
Yes, Turkey.
In the country of Turkey?
Yes.
Turkey. There's also
Turkey, and in Ukraine. And only during this testing we can take characteristics of this system and change these characteristics. Next generation.
So why can't you collect data when it's flying under AI in Babel?
I think next stage, and in this year, I think in maybe October or November, we plan give our drones first our drones on the battlefield.
Does the YOLO chain embedded AI actually power the drone itself?
No, only for recognizes and detects on target. For control of our drones, we used another algorithm.
What is the name of it?
Name of this algorithm? We create this algorithm, our team, and it's and our pilot. It's standard pilot, but for the change our pilot companion. This algorithm using computer companion on the board. It's not model neural network.
Has this drone been proven to work yet in a space where Russia isn't flying their electronic warfare? Has it been proven to be successful yet?
Yes. Our drones can use on the battlefield without involvement from warfare system, Russian warfare system, because when our drones fly in autonomous mode, Russian equipment can't destroy our drone, because we don't use the radio channel.
Yes. So, have you been able to develop a mixture of experts with your convolutional neural network that recognizes the target, and then another convolutional neural network that allows you to navigate?
No, maybe in the next, not now. Now we create only the last part trajectory in this first version, in autonomous control on the last part trajectory, not without, not on long distances. Understand? Not now.
To counter the electronic warfare,
yes.
you're going to need to do that.
Yes.
Other questions?
What is the success rate in the current model of the AI, its ability to segregate between the brute forces versus like the rest? Like say like if they're in a battlefield and like there's a Ukrainian team and Russian team that's on the same battlefield, can the target selection portion of the AI distinguish between the two?
How do they know if
So
the
it
voice
was
is a
right.
good guy or a bad guy?
Yes, thank you. We think that in deep of territory, we don't have our deep in aggressor territory. We don't have our equipment, but on the battlefield, we need operator sets the target for attack for our drone, and after that, without involvement from Russian warfare system, we can do autonomous attack for this target. Thank you. Oh, please.
If an adversary were to, say, capture one of these drones in attack, is there any concern about the person moving?
Oh. Yes, understand. Thank you. No, because we have algorithms that can destroy our model on the board.
So how quickly does it destroy it?
How?
How quickly?
How quickly? It's immediately, because it may be several ways for destroy this algorithm, and maybe flash.
Explosives also. But what about encryption?
Yes, and maybe encryption too, because yes, we can this crypto algorithm. Yes, uses
Crypto, yeah.
algorithm uses on the board. Okay.
Thank you very much. Let us thank the speaker.
Thank you.